What is up, people? So I do apologize for the long cut that off for the long wait. I do apologize on that. Today's gonna be an interesting one. I'm still waiting on if I can get the young man to be punctual, Sasha. He was wanting to present his trip to LIGO. I thought it was gonna be a very, very interesting presentation that he was gonna have. I'm still waiting to hear from him. He said around this time the show must go on. I'll change the title if he shows. Other than that, I'm just gonna throw the link in the chat because, like I said, that's what was planned. But until he gets here, this is what we'll do. Again, we're gonna want to keep it either topic pointed or respectful. I don't want none of this, none of that crap where it's like, hey, let's talk about some drama that's going on because that sounds fun. No, it's not fun to me. Not interested in it. And yeah, that's how I feel. I definitely wanted to talk about Jose's trying to do 16 at once. My apologies. But on Jose's panel, when I got the opportunity to have an actual decent conversation with Riley, and more importantly, the troll Arwen got to interject as much as he wanted, as much as he could. Same with Chemo. Chemo and Arwen are like the most useless people ever. All right, let me see if I can hear everything. What's up, Barney? How you doing, sir?
Hello.
How have things been?
Good, for the most part.
I got the opportunity to talk to Riley today on Jose's panel, and I actually enjoyed it. He didn't get an opportunity to do that word mess play thing he did, but I definitely got the opportunity to show him some papers that I've been trying to. One of them being the whole you have to be able to manipulate the variables. Like you have to. There's no ifs, ands, or buts about it. And I remembered seeing
it's a nice bonus if you can.
Exactly. And I remember seeing a paper that basically discussed variables. That's all it talked about: independent, dependent, and then the in between, which would be like a non manipulated variable, basically independent variable. Yeah, there you go. And right dead smack, it's right there, and it became a what was it? It said time, color. Let me see if I can find it. It was time, color.
I saw that
else.
bit. I took my kids hiking, so I would tune in very infrequently, but I saw that specific bit.
Yeah, that was that was a good one because a lot of times, like all these times I've ever had a conversation with Riley, I mean, last 2, 3, not it hasn't been that way, but before that, I need to be prepared. I need to know what I have. I need to know what I'm going to be looking for. Otherwise, I get like very hesitant. And when you're talking to Riley, that's what he wants. That's kind of where he plays at. He wants you to be unconfident about what you're saying, and the second he catches it, he'll just start digging in. And between me, Dress was there on the panel, and I think it was somebody else. I forget who it was. We kept it topic based and checking on his clarification of things, because the second we got to that part where it was, like I said, a non-manipulated variable, and it being though it was 3. I know it was 3. I forget the third one. Oh, there it is. Perfect. Let me see. It was time, color, and don't remember. I was just looking at it too. Damn it. Control variable not. Well, nonetheless, I think we'll just go over to freaking Jose's. I'll find it. No, but basically, it very much states that there's certain things that you don't need to manipulate to experiment on. And it was so basic, but I hate to say, chemo helped me so much. He said right off the bat, because we were talking about these non-manipulated variables, and um, color was one of them. And then Riley all of a sudden said bees, and how and bees and how they collect pollen. Well, I've always had a rough idea of how it works, where they actually they see these flowers like nothing else. These things stick out to them, and these type of flowers have pollen. Chemo wanted to say they smelled it. And as far as I know, bees don't have a respiratory system like we do to have a smell.
Oh, respiratory system is not a requirement for smelling. The fact that our sense of smell is in our respiratory system is incidental.
What is there? Okay, that's something like a dolphin or sea creatures, basically.
No, something like insects.
Well, sharks don't smell, but they smell the air, like what I'm thinking.
They will smell with their antennae, which are not part of their breathing apparatus, which is in their asses.
But is that a smell or is that a receptor?
Yes.
Okay, so it's not.
It's the same thing.
Okay, yeah.
Right? You have those organs in your nose, which is convenient because you can suck air in through it to pick up scents, but they have their breathing openings. I forgot what they're called in their lower abdomen, but their smell sensing is in the antennas.
Yeah, I'm trying to see if the dog's gonna start freaking out in a second. Hang on. And if he does, I gotta mute up real quick. Because he is loud. Oh, that's why Barney's slow. No. So when I looked up, in the case of the bees, they actually there's actually lots of studies on this. And what it is if I remember correctly, they've come to the conclusion, or not the conclusion, or I guess the conclusion of most studies, that bees are able to emit a wavelength, some type of wavelength, and obviously the ultraviolet light that they're able to see, which is correlated with these plants that have pollen. They did a bunch of studies to see if like a plant that wasn't brightly colored but had a different smell, and the bees would go to it, but then immediately go to the ones that like had pollen. But it's a color thing. You can't change that variable in that situation either. The only thing you could, I guess you could change the different colored flowers, but can't manipulate that. The colors are the colors, and they see what they see. Is that the right way to say it?
Yes.
It's definitely not complete. I know. It's a start.
It'll work.
Yeah, so it's one, and then I personally tried to stay away from it, and it came up anyway. Gravity, and again, it didn't. Luckily, it wasn't maybe a 3-second conversation because R1 and chemo screwed that up real quick. Thank God. But just the idea that I think Toady had came on by then, and he said, "Hey, how are you using? How are you gauging what's currently used if you don't believe in a gravity?" Then they started talking about the relative density and all that kind of stuff, and it was pretty clear that he knows he's denying science, and he's trying to see how far he can bend it before someone goes, "Oh nope, we're not even talking to you about that anymore," and he's loving it.
Yeah. A lot of them are just milking it for that moment when they manage to scramble your brain, right? When they say something that you actually really need to process before you reply because you've never thought of it that way. And then you go, for a second, and that's all they're after.
Mm-hmm.
And Riley especially.
Oh yeah, and if there are other flat earthers out there that may not even know, like even a basic knowledge of whatever the topic is, the second they see the flat earther with the upper hand, they shout for the win, and that's all they care about. It's not a fact based.
I scored a point. Yay! End of the game. Let's end it here. Just everybody walk their separate ways.
Take the ball. After we score
Take the trophy.
Kick the ball over the fence.
Yeah. Take the trophy and run.
Exactly. And it's and nonetheless, it's one of those things that I'm now, and it's weird because now I'm really starting to see exactly how the conversation needs to roll, because I feel confident in the stuff that I want to talk about, but it's always about keeping my tempo, keeping what's important in the information I want to get out. I'm trying to sort that stuff out, but I'm now starting to see where their cadence is, where they're they're looking for it, because I'm able to stop and slow down now. And I hate to say it, but that's thanks to 24/7 Discord server, because they're always rah 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 rah, and the second you get amped, they'll boot you. So I'm purposely having to keep myself calm, focused on the conversation, and it's just a lot of things that are happening that are just so clear. Not sure. Did you see the free-minded the guy? There's a guy over there named Bong. They were having a conversation about an observation of the moon, and one was in Japan. Okay, so one's in Japan, and one was in Australia. And literally, he's explaining what they're seeing to somebody else, to a third party, and he's saying, "Well, how come I see this? Bong sees the same thing. Hey, it's a little. Here's the best part. It's a little tweaked, but we've seen it in the same face." And right then and there, I went, "Wow." He either doesn't get that moon has to be far away for that to happen, or is everything's just so jumbled up in his brain about how it could work that he's not seeing it clearly. Because listening to those two talk about it, it was like, wow. Because there's another guy over there, Gio, and I told Grim yesterday, he actually has a better, I want to say understanding, because he speaks confidently when he's talking about the globe model, but he talks about it very understandable. Like he sounds like he understands it very well. He's almost more detailed than most globers I hear talking about it. And
but
then
Grim's not a flat.
No. It wasn't Grim. It was someone. I was talking to Grim.
Okay.
Me and Grim were talking to this guy when he was doing this, because he kept saying, he was describing how the Terminator line works. He was describing how the observations of the moon we see, and then he said something that was just wow. He said, "Well, light only travels so far. How far? 2,000 miles." Okay, well, for one, we're talking about an observation right now where the sun reflects its light off the moon, and then that's the brightness that they're seeing in these two completely different locations. That's all far more than 2,000 miles. So therefore, we shouldn't even see the moon at that point. Well, it could be 8,000 miles. Oh, wait. Could be 12,000. And so it wasn't that his numbers were getting better. It was that he was understanding that moon had to back out to make sense. That's the part that gets weird, because at some point he said, "No, I don't want to go anymore. I got to figure it out from here." Rather than, how far do I really need to go out before that face is on both of us, we're both seeing the same face with a different orientation. Why is the orientation wrong? Because that would matter too. And that's just the way it is. It wouldn't work if then their whole idea of how the moon is shaped comes into question. Because if it's a plate, flat, like they think Earth is, then at the farthest reaches of where these two had the observation, that plate would have to be standing up, not laying flat. but then they would have seen different sides. So no matter what, that ball, it had to have been a ball because we see the shadows. We know that thing had to be far off, and it's not flat in any sense because we would see a flat object. Why would that flat object be standing up? And then at that point, there'd be no way for you to know if it was flat. But they're shadows, so we know it's not. The way the shadows contour on the moon in the craters, we know it's not flat. It's just shapes don't work that way with shadows, I guess. Again, and here's the thing, Barney, that I really like to preface now. Everything I've described, whether it be sun, moon, still works. Nothing conflicts. Why aren't they seeing that?
I've been talking to Plain Truth about that very same thing. Like there is one solution which could work for explaining those individual phenomena, which is and a lot of people actually give that solution, that these are optical phenomena, that these aren't real things that we're looking at, that we are looking at things which are relevant and related to the position of the observer always as optical phenomena.
Wait, is that the personal sun idea, or is that the...
Yeah, that's the personal sun, personal moon.
Well, if that's the case, then damn, we all think alike.
No, that's the like, if the Earth is flat, if we see the things that we see, that is a necessary solution, right? That solves Eratosthenes' experiment. That solves our different observations, where you would expect to see something drastically different from a different point of view. It is the statement of, like, do you know how rainbows work?
In a sense, yes.
I think I've said this previously on the panel. Like, if the sun is directly behind your head, and you put the line from the sun through your head, and then from your eyes draw a cone at 20 degrees from that line, right? Mm. Your rainbow will be on the circumference of that cone. It will be at 20 degrees.
Your personal rainbow.
Every person that sees a rainbow are the only person seeing that rainbow at that place and that time. Person who is standing next to them will see a slightly different rainbow moved to be centered on their line. Right.
But the problem with that is that object then cannot be physical.
Yes, and that's what they say. It is an optical object that is not physical. It is a personal optical illusion that we see now.
But
the problem with that is that the rainbow that we see is an optical illusion created by the sun, which is emitting the light. Now, if the sun is an optical illusion, what is the physical object that's creating the light? And what is like for the rainbow? We know the mechanism, how it works. We know the optics, like all of those properties of refraction, of optimization of light. All of those things come into play of spectral, like splitting up white light into spectra. Like all of that fits into explaining the rainbow. There is nothing explaining why the sun would be where we see it is and how that would work. And I'm not even sure that, like, probably you could come up with a very, very, very complicated way of describing everything to get it to fit that.
But
the thing that you would be describing would be an illusion that makes it look as though as you're standing on a sphere that's 40,000 kilometers in circumference, spinning at 1 revolution per 24 hours around the sun, which is so many million miles away, right? So it would be an illusion which perfectly coincides with everything that we know today, right? With everything that.
And I was waiting for this one. Except that would put a situation of the two light-sourced bodies in the sky, like you're saying with the sun. Their argument that the moon emits light would then be void as well. It can't be the source.
No, it's not the source. In the same sense that the. Is somebody dying on your end?
My son's sleeping in the back behind me. It's not my fault. That's how he is. I can't control his sleep.
In the same sense that the rainbow is not giving off its own light; it is just reflecting the light from the sun.
But the sun's not. Sun's not emitting light, though.
And then we would get to something like what Pichea is saying, that those are reflections of objects unseen and unknown beyond the Aristarchus roots.
Oh, the invisible stuff.
Yes, we don't know what they are nor where they are,
but
we can just see their reflections.
See,
though they can't be reflections because they're acting in a way which is inconsistent with reflections.
Well, I've heard it interesting as I thought to this light issue, and it actually seems like it's actually how it is. Period. The idea that it takes 8 minutes for the sun's light to reach the surface of Earth, we don't see the sun. Or we see the sun, but we don't see the current sun.
Yes, we don't see the current sun. We see the sun 8 minutes in the past.
That's crazy.
Yes.
But if you're seeing it continuously throughout the day, nope, it still doesn't come. No, we're screwed. Yeah, that's one of those sucky things. Then guess what? If something happens, we don't fucking know. Not for another 8 minutes.
That was one more indicator that Newton was wrong, because that was known kind of almost immediately after Newton explained gravity. It was known that he was somewhat wrong or something. Again, those two solutions for dark matter, right? Either our theories are completely wrong, or there is something that we're not getting. Newton was assuming that gravity and light and all of those effects happen instantaneously.
Yep.
That their speed is infinite.
Which would be impossible, because
we didn't know that back then.
Okay. Right?
That was an unknown, and he kind of assumed it, and for all practical purposes, that's true. It takes significantly more effort to measure the speed of light than it does to measure the speed of sound, for example. But they noticed that when they observed the motion of the orbits of the Jupiter's moons, when Jupiter was at its closest and compared it to when it was at its farthest, Newton's equations just didn't explain completely their motions. It's like their motions were retarded when they were further away, slowed down. All the moons were late from where they should be. And that shift happened gradually as it moved away from us. And then when it got nearer to us, it would start fixing itself. And then when it was closest, it still wasn't like we would take that as just right. And that's the delay, because when when it's at its closest, it takes a certain amount of time for its light to get to us. But when it's farthest, it takes a lot more time to get to us. So we see the image, like when it's moving away, we kind of see a slow motion movie. And when it's coming towards us, we see it speed up to catch up, right?
Yes. Well, and to finish that point off, because that's when I realized how that worked. It was, well, oh yeah, by the way, if the sun were to disappear, we'll say magically, like flat Earth evidence, it would not only would it take the 8 minutes to figure out the moon is gone visually, or the sun is gone visually, but then pretty much at the same time, I think a little slower, we lose orbit, or Earth will then leave
same
it.
time. Same time.
Way I understood it.
Possibly,
it's not the same, but
possibly a little faster, because
gravity doesn't travel faster.
What? No, it doesn't travel faster than light, but light doesn't travel at the speed of light. It only travels at the speed of light through vacuum, and the interplanetary medium is not absolute vacuum.
So even our atmosphere, not our atmosphere, our electromagnetic field and all that stuff, that's going to play a part in the time between what we see and what we don't see.
Yeah, the plasma and the particles and the gas and all of those things will slightly slow down light.
So then, oh yeah, well that's exactly why it could be faster, yeah. So yeah, that's not really ever explained either. Where yes, the speed of light, nothing can travel faster than the speed of light, but never to think the speed of light doesn't always travel the speed of light.
The light doesn't move at the speed of light.
So okay, so then, and to keep it real, the speed of light is an unobserved number.
Yes. Oh,
well,
more or less.
In the sense of we can't have a perfect vacuum.
Every measurement that you take as an absolute value is an unobserved number. There are no perfect measurements.
Well, they can't create a perfect vacuum, therefore they can't have a perfect vacuum speed of light.
Yes, and you cannot measure things with perfect accuracy. And when you get to certain level of accuracy, you get into the problems of quantum physics and Heisenberg uncertainty and quantum tunneling and stuff like that. Right. So there is, like, as you try to make your precision on one thing narrower and narrower and narrower and narrower, you kind of start losing focus. You can never measure anything perfectly.
Yeah. Okay. Well, yeah, okay, I get that 100%. Yeah, because if you look in the record books, the speed of light has changed numerous times based on the technology and the accuracy of how we're able to measure it.
Yeah. Well, technically, the speed of light has not changed our measurement.
Damn it, Barney! It's too early for that shit. We're doing so good. Yeah. Well, that's also the other thing. I wonder if. Well, see, that's the idea that, you know, for instance, and it's kind of just throwing in there, we didn't go to the moon, for instance. My biggest question is we're talking about 60 plus years ago. 60 years ago. Why can't technology be good enough to get to space by now?
It is.
Well, I'm saying in a flat earther's eyes.
If we were willing to take the same risks and do it in the same way that they did, we could. It would take us approximately 10 years as it did them, maybe a little less, because we would need to get people to that level of expertise with those technologies that they've had back then. Right now, we know more, but we don't know it better, especially in the engineering department.
Mm-hmm. Yeah,
Right?
I see what you mean.
Because those people had the hands-on experience of working with those things for 10 years and having pretty much their hands untied in inventing completely new ways to do things. And like when you look at some of those things, how they assembled those rockets, you literally had a high-level engineer come in with a hammer and say, "Okay, this needs to be a couple of microns shorter." Dun, 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 dun.
Oh yeah.
Okay, now it's a couple of microns shorter.
If you get a chance, look back into my videos. I did an interview with a guy named Dandy Pandy, and he was like a Apollo nut. Like he grew up during the Apollo times. He's an engineer, and basically he really laid that part out, like how they were trying to cut weight so much they were bidding on like bolts on certain sections that could be shaved just enough that could be strong enough. It was like, wow,
Yes,
like you really get to understand why it was so tough. How matter of fact, how it is possible because what they went through.
and you had that master of crafts effect where a guy could walk up to a shuttle booster rocket. Well, back then it wasn't the shuttle, but same thing, right? Walk up to a booster and those, sniff it, scratch it with his thumb, and say, the third nut on the second coupling is a bit loose. It needs to be tightened by, right? Those kinds of guys that knew their stuff because they lived it and breathed it for a decade. Once that has been disbanded, and later on when the shuttle program has been disbanded, we have kind of lost that. Those people have retired and or died. Nobody has been doing that for decades. And while we still have the same maths, it would take time to, and it does take time to rebuild all that. And in some instances, it's simpler to rebuild it from scratch. Another part is when they were doing it, they did not have corporate space. They did not have the producers of the engines and parts for the shuttle trying to lobby the Congress to approve only the projects that would buy their parts because there was nobody producing those things. Nobody was, right? Mm-hmm. So they could invent new things without politics getting involved. Now that's no longer the case. Now the next generation of US rockets is being built to reuse the shuttle parts as much as possible because there are already producers who produce those parts who are lobbying to have a big client buying those parts. So it's a lot more constrained in many ways.
It's I again, it's one of those points where it's like you have to. You can deny as much as you want, but there's just some things that realistically you can't even have an opinion on if you don't have a full understanding of what your opinion's even discussing. I'm sorry about that. My phone just went off. That's what I'm trying
What
to
do
say.
you mean? You can't have an opinion? Everybody can have an opinion on everything. And
Yeah, but the
everybody's free
second
to
they
voice
say,
their opinion about anything.
but the second they say, "Nuh-uh," their
Yeah,
opinion becomes a little less valid, and that's
that's
kind of the
their
frustrating
opinion.
part. Yeah,
That's just
unfortunately.
like your opinion, man.
Well, yeah, I guess I kind of gotta understand that, seeing how gravity is a force.
No, it's not.
is.
Yes, it is.
Yeah, exactly.
Yeah.
I'll even say it's not. So you're never going to
But
catch
not
me doing
really.
that. But mostly. In any application I will
Only,
ever use, it will be.
yeah.
Damn,
In
actually,
the same sense that centrifugal force is a force.
I'm gonna try to.
It is a
Well,
force only if you're using the wrong frame of reference and the wrong measuring system.
see if this will work. Because I want to actually want to show you. I wonder if this will work. I wanted to show you the moon observation video. Cause I just finally found it. That that me and Grim were having with the other guys at the 24/7 server. Let me see if I don't even know if it'll work this way. Hang on. Oh, now someone wants to come in right when I start sharing. What's up, Blue Marble? How you doing, sir? Let's see if this will work. I just admitted him. Oh, there he goes.
Hey, what's up, guys?
Not much, just kind of BSing. Oh, hey, Taylor, it may work. I think this may make it so you guys can hear it as well. Hang on. Screen. I'll move this over here. And I'll move this back over here. Alright, let's see if it'll work. I'm going to try to play through my speakers, that way you guys can hear it.
I don't know about y'all question, but I think my question is similar. Because we went over this about 2 nights ago when me and Bong were both looking at the moon, right? I'm looking south. I'm in Japan. He's in Australia, right? I'm looking south. He's looking north. We can both see the exact face of the moon. The moon looks like a plate staring at me. I can see the exact face that Bong can see. How is that possible? It's just, okay, it's flipped. Like his little sliver of dark side was on the opposite corner of the moon than mine, but we're looking at the exact same face, and we're both opposite of each other. I'm looking south, he's looking north. How does that happen?
Yeah, that's crazy to have to hear that in retrospect.
No, but hey, Jill, I think that the question is, and I don't know what.
All right, yeah. So get rid of that. Back to here. All right, perfect. You guys were able to hear that, right?
Yeah, we heard.
Okay, cool. Let me switch back. Yeah, and it's weird because they described exactly what you're supposed to see on a globe, and then they question it. But it's like they're already convinced it's a globe. On a globe. Oh, no, it doesn't have to be, Barney. When you say it like that, it sounds disingenuous. God damn it. Why? From what? They're not cooking on a stove. Oh. All right, so what? So now I remember what I was getting back to. So the whole reason I even had brought all that up with the moon again, because on Jose's panel, I was trying to have a conversation about the sunrise and sunset with Riley, because they were talking about that, and I mean, there's only one way this could happen, and luckily I think I have that one as well. Or Earth is seriously fat came on a couple of streams ago, and he had one of those 3D topographical maps, and it was pretty damn cool. The problem he had is that the second me and Dross saw it, we were like, hey, you'd see what the sunrise and sunset would do on there, depending on which view you thought it was. So he showed it I'm gonna try to find it. He showed it as it was his camera phone, aka the sun, was far away, coming closer to the mountains, and you see the mountains start dark and then get dim or then brighten up as you get closer, and vice versa, going backwards. But then he did something that was wonderful. He put it like below the horizon, below the table that he was on, and he raised it up slowly, and you see exactly what we see every day, or we observe, where the top of the mountain becomes lit, and then the whole mountain becomes lit as the sun appears to rise. It was, and like I said, these are all within the last 3 days. So right now, I'm fairly convinced there's a lot of flat earthers that are just trying to get enough people to hear it and go, "Hey guys, it's not flat." And that's just the way it's got to be from now on, because it seems ridiculous. What's up? We will. Well, apparently so was I. So I didn't act as I was supposed to. I was just an insubordinate flat earther. Hmm? And it doesn't really get any better than that, really. Barney, gravity is a force. That's what he does now. That's like all he wants to do now. What does Sean say? Opposite. But mhm.
You have muted the panel when you played the video.
I fixed it.
So the live chat is screaming that they can't hear your panelists.
Well, guess what, people? You should be used to it by now. I always do that kind of shit. Congratulations. If you've never heard it, you've lost 3 minutes of a conversation. Too bad.
Dang. And it was the best part, too, because I was speaking.
Yeah.
But anyway.
I mean, no one missed anything. Put it that way.
Oh, dang. Cheap shot. Cheap shot. Anyway, but as I was saying, you would think that as flat earthers through secret, they would look in for answers, and they would stay objective and open and neutral, which is what they preach. But yet, when it comes to the flat Earth, it's just like a search on any other explanation that halfway makes sense to explain our everyday experiences and phenomena that are not as other than their mainstream well-known explanations. It's what it seems like. It's like, why the heck would you have to grab a Fresnel lens or a magnifying glass and say, look, light can bend, and make it look like it's coming from somewhere else, but only somewhat explain one point of view, one phenomenon, but not explain the rest of them. It's like, I don't know, man. It's so crazy.
That's what worries me. You really, the only people that it should be affecting are people that have just no understanding of it. But there's such it's like a long line of people that want to jump in and go, I know why it's flat. And it's like, how do you know it's flat without being honest with yourself?
Well, it's like the last 3 episodes of Globebusters. They've been bringing up all these videos from P-Brain, and and it all goes back to perspective, and they just make it up to be such a complicated thing, and it really isn't. It's so simple. All you need to know is geometry, basic geometry, and make 2 lines from your eye to the top and bottom of an object. And then the further it goes away, the more narrow the angle becomes, and that's it. Period. Angular size changes according to distance of an object from the observer, and that does not explain the sun being able to never go below the cloud ceiling and yet shining under the clouds. That doesn't make sense.
Yeah,
That's, parallel lines by definition will never intersect. And if you think about the clouds as a mirror, when you bounce a light ray from a mirror, the angle is going to be the same as the angle it came in when it comes out. So if it comes out 2 degrees, it's going to come out at 2 degrees. Well, guess what? In order for the sun to be under the clouds and be able to have an angle from the top, from the bottom up, greater than zero, it would have to be below the cloud line. Period. There's no there's no magic that you have to think of or whatever. That's just how it is. Period. There's no way.
And the
And
closest I know someone to have been, believe it or not, was Chris Berry. And the fact that remember the Mount Rainier experiment he was doing, all that stuff. It's at the very best you could do is the albedo, of it, whatever it's shining off of. But otherwise, there's nothing you can do.
I think the problem is on that specific scenario. Sean, what's his name? Hawkins. He never, he said that there cannot be the sun can't cast a shadow under the clouds. Like we were seeing, and he didn't specify that that it was the light source itself. Because yeah, sure, if you had a majestic giant mirror, the sun can be above the clouds and bounce off of that mirror and cast a shadow on the clouds. Sure, but we know that that's not what's happening. We can clearly see that is the actual light source. We can see, we can tell because of the sharpness of the shadow. Otherwise, you would see multiple shadows, and you'd be able to see the 2 light sources. Especially if you're on the top of the mountain, we don't see that. We only see 1 light source, the sun. Period. If the sun, once the sun hits the clouds or the ground, that's going to be a scattered light because the surface is not slick, and it's not the angle, the reflections are not going to be perfect like they would be on a mirror, perhaps. So yeah. Anyway,
Yeah, I see. I'll continue on, and I'm working on shifting myself out of the browser so I can.
Yeah, I hear you quickly clacking.
Yeah, hang on 1 second. No big deal. I'm just trying to figure out if I can do it this way or not.
Yeah, I'm actually working on a video because I'll be wanting to do other stuff, but I need to knock out this stupid perspective thing, and I'm gonna use the mountain example, and I'm actually gonna model, the objects moving away from an observer, changing the angular size. I mean, I got so much positive response from my other video, from bringing it down to a model and just a basic thing that I think that's just what I'm gonna do whenever it's possible. So
awesome. Yeah, what was I gonna say? It's very important that how do you say? You got to make it clear to them that, and they'll use it. Perspective isn't it doesn't explain anything. It's just what you've done.
like Slick would say, perspective is, period. It's a byproduct of three-dimensional space. That's a byproduct of it. From an observer, you will have perspective, period. And then you don't have to account for perspective on a calculation for curve, or if you're looking at what do you call it, like a side view of something. Help me out with this. What's it called?
Orthographic. Yeah, an orthographic view. All that is an orthographic view. Let's say it doesn't exist. All that is a cross section of the 3D real world. That's all it is. So it does exist. It's just a way to bring it down to a 2-dimensional space to be able to be illustrated. If orthographic view or whatever, if that wasn't something real, then I don't know how the heck architects will be able to plan stuff and build stuff. Anyway,
don't confuse that with a section view. It is not a cross section.
Well, what I say,
it is a straight on view.
Straight on view.
Yeah, just straight on.
What is?
Typically, orthographic. Just means straight. Just means straight on.
Well, you're saying that not to confuse it with a cross section.
Yeah, a cross section view is a cut through something.
Right. Well, I mean, in theory, well, yeah, exactly. It's what it is.
We can draw a cross section view. We can draw as many cross section views through an orthographic view as we'd like. You know, in the perpendicular direction, to show various features that you can't see from the outside.
Right. But I mean, in theory, when you do, like, say, you have a square. I'm sorry, a cube, and then you have an observer on a plane, right? And then when you make an orthographic view, you're just showing in 2 dimensions the side view, right?
Yeah.
Now, if you were to take those objects and cut them in half, you know, from the top to the bottom, you know, and you like a slice, then that's basically what you would get, the orthographic side view. That's what I meant by cross section. But you know, it's not to be confused with that. But yeah, that's basically what I meant.
Yeah, in engineering, when you cut through something, yeah, that is a true section view. You're seeing the inside of it now.
Gotcha. Yeah. Orthographic, you're right, because orthographic, you're not actually. It's a little more simple and not actually showing any details. Yeah. You're just representing it on a 2-dimensional.
Yeah, you can have, in theory, 6 orthographic views of any.
But an orthographic view would be very similar to a cross section, right?
But you can have orthographic projections in other planes too. We typically think of, you know, front, back, left, right, top, bottom for orthographic.
Gotcha.
But if you've got some angled surface, you can project that out and look at some other angle. Look at it flat, straight on from some different angle if you want to, and make an orthographic projection that way. If the thing has got features, if you look at it from the front and it's got a hole through the center of it, we would draw that with dotted lines, okay, to indicate those hidden lines. But if you wanted to see the detail inside, you take a cut through the hole, okay, and now you actually see the edges, the sharp edge, the edges.
But the silhouettes of the objects themselves would be similar to our side view, is what I was saying.
Yeah.
Gotcha. It's just more detail.
I'm bringing all that up because some fucking flurf that has taken mechanical drawing will call you on it if you start talking about it.
And I appreciate it, because they will definitely call you out on stuff like that. But anyway, you got what I was saying, but you know, technically,
I know what you're saying. Yeah, I'm cleaning up just the
clean up my mess, man. Clean up my mess.
Nitty gritty details because of the way these shitheads operate.
Yeah. Well, today Bob Nodell was showing how the distances, and the angular sizes of things in the sky, and then showing like our eyes can only see to a certain angular size. So I commented, I said, you know, he said, you know, after a certain small angular size, you have no resolution. You can resolve stuff, you know, objects and stuff. So he's saying it's impossible to see certain stars. So I commented and I said, what's it called? You can have no resolution, but you still can detect light. And then Jared was like, I don't know what that means. And then Bob was like, well, I know what he means by that, but yes, that's true. He said, you're actually right. But then he brought the inverse square law. And then he said, but because of the inverse square law, then there's a limit of the distance that we can see something. And I'm going, you just contradicted what I just said. You agree with me and then contradicted with me again. So anyway, but
the inverse square law says that with the square of the distance, you will be receiving less and less light from there.
Exactly.
Never actually reaching zero. Yes, it might diminish and diminish further and diminish further, and ultimately you will get to having 1 photon per minute. But if your exposure is long enough, you can still image it.
I know, and that's what baffles me because he's used telescopes before. I think he just never used telescopes with a digital CMOS sensor or something like that, where you can actually expose for a longer amount of time. Because that's how you freaking bring more celestial objects into the view and more detail. So I mean, at least he agreed that I was right about that. But then he just brought the inverse square law, which, as Barney says, that just says that it's going to get dimmer, and but it doesn't mean that it's going to be to the point where it doesn't make it. So, the
reason we only see 3,000 or so stars with our naked eyes is exactly that, the inverse square law. There's just not enough. Our eyes aren't large enough. We need we need much bigger eyes to collect a lot more photons if we want to see more distant things. With your naked eye, you see 3,000 stars. You buy a cheap telescope and you see 10,000 or 20,000 or 50,000 stars. And get a good telescope, you see millions of the fuckers.
Hashtag we can't see forever. Freaking Eric Dubay.
Yeah.
Yep, that's where it comes from.
That's actually Aristotle.
Wow, we can't see forever?
Yeah.
Well,
Aristotle had an explanation of sight, of vision, something like there is an essence of sight in our eyes which shoots from our eyes like fire and illuminates the things that we see.
And some others actually believe that we see stuff instantly. The light does not travel. And but Eric Dubay in the very beginning of 2015-14, his little videos, we can't see forever. I'm like, yeah, fair enough, but that doesn't explain what Anyway, it all goes back to perspective. I can't believe it. It's been 5 years and we're still not really getting a grasp of perspective. Well, it's a combination as far as the sun setting and stuff in the distance. It's a combination of perspective, atmospheric dome of view, whatever that's supposed to be, atmospheric magnification, and the air is dirty. I don't know, something like that. Those are the excuses for why we can't see, further, and why the sun, sets. Yeah.
I have no idea how anybody has managed to make it through 5 years of this bullshit. I've barely been doing it 5 months. And I'm sick of it.
I think we all deep down have this hope that one day we're gonna have somebody say, you know what, you're right. And I think that's what fuels our desire to go back. But I don't think it is. I think it's just a matter of not wanting to stand by and letting people just speak all this nonsense. I just can't. I have to say something.
Guys, come on. If at any point this becomes not interesting to you, not fun for you, if you do not gain value for yourself through doing this, please stop doing it. There are better things you could be doing with your lives.
No, I really have learned a lot since I got into this mess. So
yeah. So the frustration of hearing those things for me is bearable for those rare gems that actually make me think about something.
I learned my lesson.
Yeah.
Yeah. You did.
All I'm making sure is that when my kids get older, prepare them, and so nobody can catch them off guard and come home and say, "Hey, Dad, did you know there's penguins with AK-47s in Antarctica?" Something like that. In fact, I explained my daughter a few months ago why the sun and the moon seems to follow us, and every time she sees the moon, and she's like, "Hey, Dad, look, parallax." I was like, "I'm so proud of you." So she knows what parallax is.
I was listening to bits and pieces of Jose's stream today, and I was
Yep.
taking care of my kids, and I've misplaced my earphones. So my 4-year-old son walked up to me and asked, "What are you listening to?" And I said, "Some guys arguing about whether the Earth is round or flat." I said, "Oh, they don't have to argue. I can show them pictures."
Hashtag indoctrination. Well, my daughter, she was watching me. I was watching a video, and this guy was talking about the Earth, and about how the radio waves propagate. So I've been doing some research. She said, "Yeah, does that guy knows that the Earth is round?" I was like, "Yes, baby, he knows the Earth is round." I said, "What do you call people that are not flat earthers?" And I said, "Normal." Started laughing.
How?
But anyway, yeah, she got a kick out of that. She's over here laughing at me right now. She's only 7, but she cracked me up. She said, "Dad, what do you call people that don't believe the Earth is flat?" I said, "Baby, we're normal. That's what we call them." Oh man, I couldn't help but laugh. But I did tell her, I do teach her to be respectful and tell her, people are entitled to their opinion. Just be respectful. So anyway.
I got some awesome pictures of perspective from the weekend that I'll be uploading later this week.
What, RC stuff?
Yeah, I went to a scale truck comp over the weekend.
Do you have like a Facebook page?
My personal Facebook, yeah.
Do you upload pictures and stuff over there?
Yeah.
Okay, I need to find you then.
I'll send you a message on Discord with it.
Okay, sounds good. All right, my kids have found a roach. I gotta go. All right,
Here,
talk to you later, guys.
Here, Carlos, hold on. I know everybody.
Oh, you're gonna put it here on. Okay, yeah, I'll get it from here then. What's wrong, Emily?
You can't miss it. It's got a picture of the sunset taken with my drone. Those are nice.
It's a tube. But it's not a YouTube, it's a them tube.
So like, if you go take the LIGO tour, do they just take you through all of it, or let you take it?
They can only walk the length, or they can only walk the length of it when it's turned off, when it's not working, because it'll detect footsteps. So literally walking next to it while it's operating will destroy your results.
Damn. That's awesome.
This is the one that, where is it? Up in Washington or somewhere? Montana. Yeah. Somewhere up there, yeah. It's one in Louisiana, right? One. Yeah, that's not Louisiana. I know. I've been to Louisiana too.
I know. No one could hear me a second ago. Too bad.
What were you saying?
All right, gentlemen, you guys have a good evening. Sean, everybody in my car is pissed off because I made them listen to your show yesterday while I was driving, or Friday.
You're who?
Car.
I was in my truck on my way to the event when you were live streaming the other day, and I was playing you through all the speakers on my car.
Thank you. Next time you should tell me. I'll say some stuff that you probably didn't want me to say.
It's all good. Oh yeah, but I got about another 2 hours and I'm home. So
when are you gonna start going live again?
Hopefully this week, I'll be all set up and ready to go live.
Cool. Well, thanks for stopping by, my friend. I'm not too far behind you. I'm actually getting kind of hungry, and like I said, I wasn't planning on doing anything, and I wanted to set the stream up so that it wasn't just random hurry up and start when he got here. But like I said, it was supposed to be for the opportunity for him to present this LIGO stuff, but
it's all good. We just stopped at it. We called in an order to Casey's and are waiting for them to make our pizzas so we can get back on the road.
Pizza sounds great.
I also got some interesting pictures of Polaris above the horizon from 3 different locations on the way. So awesome. I'll get them cobbled together.
Yeah, and that's what I do also. Because I do talk to a lot of people on Discord and through YouTube and everything. In the probably next week or so, I'm gonna have a call to action for people to start, snap a picture facing a certain direction, south or something of the moon or whatever, blah blah blah. And I want to start putting these to question, like, that's what needs to happen. Observation shown. Why are we seeing this observation if it's flat or a globe? And I think we'll get further.
By the way, Sean, in October, the last week of October, I will be in Central America, Nicaragua.
Oh shit!
So you can get more data if you need to give me some observation.
Yeah.
Of the sun or moon while I'm down there. So that way you don't have to the United States.
Once I figure out how to crop my trophy off, there's a picture of my tiny truck in front of a building that looks like a real truck because it's all lit up and got scale roadway and everything. So.
Yeah, I'm trying to get something up here. Hang on one second. Because I don't see Sasha in here. And I feel bad because I didn't even say what's up to everybody. So I'm going to say goodbye to everybody in a minute. I don't got anything I want to promote or anything like that at all.
My channel?
Go ahead. You promote it, man.
No, you promote it. I trust you. This is your channel.
No. It's all you. How about this?
Right,
you promote it. I'll make sure it stays in my description box below so it can always be gotten to.
Excellent. Well, recently, Bob, the science guy, had featured me in one of his videos, and I have gotten over 1,000 subscribers in just a week. So I'm definitely going to be doing more Flat Earth debunking content. Last 2 videos I did were observations while once in the outside, observing light and just proving that perspective doesn't explain light, sunlight shining under the clouds. And another was some moon footage, moon landing footage. Anyway, so yeah, I want to make you more content, just practical observations using models and actually getting out there and doing some stuff with radio frequencies and satellites. So there's not that much that many videos of people actually listening to satellites and measuring angles, either from the globe Earth side or the flat Earth side. So yeah, I'm gonna make you some of those videos. So thank you, Sean, for putting my channel on your description. So
Yeah. And anytime you want, you just go ahead and throw like your new uploads, throw them in chat, man. That's so people can get out there, and then I'll make sure I share them too.
run for. Thank you.
Yeah, no problem. Anybody, Blue, you got anything coming up?
I've been trying to work on some stuff. Maybe I'll have something out tomorrow. I'm not sure. We'll just see how it goes.
Awesome.
I think what I'm going to do is I've had to ban myself from flat Earth channels, and I think I'm going to stay away from a lot of these chats for a bit. Just mainly because I start watching this stuff, and some flat Earth idiot, or even worse, some globetard idiot, says something so incredibly stupid, I feel compelled to start a new video. So I got a whole shitload of videos started, and none of them finished.
Yeah,
Too much content.
That's the boat I'm in right now. I have so many ideas, and every time I get halfway through something else comes up, and it's like, did they what? So I'm into the same fight right now. It's like, the only thing I'm trying to stay on track is basically this whole idea that everything I'm going to describe as an observation still works with everything in past streams I've talked about, and getting that through, because I've actually been spending a lot of time at 24/7's Discord, and if you can be there and know when to shut up and not piss someone off and get banned right away, you're able to actually get through some of the people that are there. It starts quieting down when there's a couple people that actually know what the hell's going down, especially with how the conversation is going.
Yeah. Well, I do want to go through this Coriolis airplane horse shit one final time, and do. I want somebody to explain to me how they think I can make a 5/1000th of 1 degree correction in my heading, because that's about what Coriolis amounts to in an airplane.
And then probably what you'll end up finding out is the lack of knowledge, period, about how flying works in general.
That's the bottom line to it. They don't understand how you fly an airplane in the first place.
Yeah, that's.
I'll tell you what I'm not going to do. I'm damn sure not going to get in an airplane, fly in the wrong direction for 12 fucking hours, and then say, "Oh shit, I didn't get where I wanted to be."
Yeah, exactly.
That's not how you do it. We're going to maintain a heading that keeps us on a course that we're trying to fly. Period. And the Coriolis is so minuscule, it's not even funny.
Well, that's also the other thing. Because I remember when Dr. Bob came on and he did the what's it called? Sky Vector. Yeah, there you go. And he was showing like how the paths are exactly how we fly, and if we didn't, the mileage would be completely off on this whole idea that you can travel. And that's the thing. Traveling in a straight line on a fucking globe. You don't understand that you can't go in a straight line. It's like, look at the flight path. I thought it was a slam dunk. I was like, oh shit, no more of that fucking flight paths are wrong and all that shit. It's literally night and day. So I say, like, some of the stuff you kind of just gotta just let it go, because it's either something that they just aren't gonna get, or something that they aren't gonna allow themselves to change their mind on.
Yeah, I'm gonna take one final crack at it, I think.
Good luck.
What you should do is basically just, I guess if the topic's coming up, just give whatever knowledge you have on it, because people like me still need to learn. and
Right.
flat Earth is fucking it up for me.
You know, and the good scientists of this earth are not always as slick as they think they are. They come up with things like this. I forget which one of the idiots pulled this thing up the other day. A thing called Omni Calculator, and it's pretty cool. You can put in mass and velocity and latitude, and it assumes the Earth's rotation, and it calculates the Coriolis force for you. And if you go down through here, you'll find a thing where this particular well, he made a mistake here. He left out a 2, but okay, he got the rest of it right. But let's see, where does he talk about airplanes? Oh, Coriolis effect on airplanes. So he talks about an acceleration of 0.016 meters per second squared, and then says pilots would need to do a proper flight plan in advance. Yeah, But at the same time, you can put this. These are numbers for a typical light airplane, like the plane, my airplane, 1,000 kilograms, about 90 meters a second cruising speed, at a latitude of say 45 degrees. The Coriolis force on the plane is 9 fucking newtons. that's about a kilogram. Okay.
Jesus.
Give me a freaking break. You really seriously think I could take that into account in a correction when I've got maybe a 20 or 30 knot crosswind blowing? No.
It's, again, not, it's complete. I can tell right now, 99% of the people that are going to say that have first zero clue about planes, or if even worse, an idea of how anything would work in that situation.
Nope.
And you typically will find that in the why don't they have to nose down? And it's like well, that's like probably one of the easiest ones. It's literally just not the amount of thrust you're putting into the plane. You put just amount in, it's not going to keep gaining altitude, which works on the globe.
It's an airplane. Getting it to go down is not the problem. Getting it not to go down is the problem.
There you go. And we just figured that out. So trust me, they're not going to. They didn't have enough time to lie about it that way. Oh, what's up, Unpaid? I'm actually wrapping up, but I'm actually gonna keep this panel going. But I'm gonna wrap up because I'm hungry and I don't want to actually just leave everyone sitting here while I'm hungry. So if you guys want to jump into the meetup, I'm gonna put the link out there in the chat. Barney, do you guys know anyone else have anything they wanted to share before I rant or put the link out there?
It's Globe. Woo!
Oh, is it? Bet you think it's a force too. No, I'm just kidding. All right. There's a link if anyone wants to jump in. I'll still be around to let you into the meeting. But I'm going to end the stream because, like I said, I'm hungry and I don't want to keep you guys sitting here listening to me rant about how hungry I am or listen to me eat. So I'm gonna get out of here.
Or hard bomb.
What's up, Chris Berry? Yeah, how about them Cowboys?
Chris, my man.
Good game. Yeah, Chris, if you want to jump on it, I'm ending the stream, but I'm gonna keep the hangout going. So, with that said, guys, I'm gonna go ahead and mute you guys in the hangout so you guys don't hear me outro out, and I'm gonna mute you guys so they don't hear you while I'm doing so.
Outro. I'm tired of seeing the elephant.
What? Oh, you want to see that? And I was telling Amy in the chat, I have actually had another one with an elephant in a funny situation, but I'm gonna go ahead and mute myself because the dog's starting to bark, and I will talk to you guys later.
All right.
Hi.
on a hangout